I would now like to take a look at acetal and ketal formation, and in contrast to the hemiacetals and hemiketals, what we're looking at here is use of excess alcohol. So that's what we're looking at, excess alcohol here, and that will end up giving us products where we have two O alkyl groups attached to the C where the carbonyl group was located. Let's take a look at the mechanisms of those. And we'll start off with the acid catalyzed mechanism first. So the H plus attacks the C double bond O. We end up with a positively charged carbon. We have the alcohol come in and attack the C plus. And in this next step, this one is a very important step, you can see that if we had just removed the H plus, we'll end up with a hemi-ketal, but in most cases what we see is a proton transfer. And as a general rule, a proton will always be transferred to a group that's going to end up leaving. We know this group has to leave because you can see we have two OCH3 groups in the product. This OH group is going to have to end up being replaced by an OCH3, so we know it's going to have to leave. So as a general rule, a proton will always be transferred to the group that is going to end up leaving. The pattern goes as follows. We have this O take the H and this bond break, and this all happens simultaneously. And really what's happening here is an O is forming a new bond to the H, and this bond is breaking, and it all happens at the same time. Because we're using two electrons from this oxygen to make this happen, we're going to end up shorting the oxygen of an electron, which is going to lead to it having a positive charge. So the next product looks like this. Now, in looking at this in two dimensions, you might think that there's no way that this could happen. This is too far away from the hydrogen. But you've got to remember that this is not a two-dimensional situation, it's a three-dimensional situation. Let me try and draw it for you in 3 dimensions, and you'll see just how close these things can be. So you see that in 3 dimensions, what's going to happen is that this O will take the H, this bond will break, and then the proton ends up being transferred to the O from the alcohol group. Alright, so we've gotten that far. Now we know that this water has to leave. And that's generally the next step after a proton gets transferred, is that the group that the proton got transferred to ends up leaving. That leaves a positive charge on the C. And now we can get the alcohol to come in, attack the plus, and now we can have the H plus leave, and we get our product.